Hi everyone, in this section we can study a shaft problem. I can read the question. A shaft is supported by two bearings placed 1 meter apart. A 600 mm diameter pulley is mounted at a distance of 300 mm to the right of the left hand bearing, and this drives a pulley directly below it with the help of a belt having maximum tension of 2.25 kN. Another pulley 400 mm diameter is placed 200 mm to the left of the right hand bearing and is driven with the help of electric motor and belt, which is placed horizontally to the right. The angle of contact for both the pulleys is 180 degree and mu is equal to 0.24. Determine the suitable diameter of the solid shaft allowing working stress of 63 megapascal in tension and 42 megapascal in shear for the material of shaft. Assume that the torque on one pulley is equal to other pulley. So first of all we can write this question and we can draw the space diagram. So I can show that space diagram. According to our question, this is our space diagram. That is, there are two bearings and the shaft is mounted on this bearing. At point A and point B, two bearings are placed. In between, we have a length of 1 meter, that is the shaft length. On this shaft, there are two pulleys. First pulley is point Z, another pulley is on point D. That point C, that is the first pulley, is from the 300 mm. We can convert it into meter. That is 0.3 meter from the right of the left hand pulley. And another pulley is at point D, that is 200 mm or 0.2 meter from the left of the right hand bearing. And that pulleys have a diameter of 600 mm and 400 mm diameter respectively. Now, in this question they have already given that at the points on the pulley C we have only vertical load and on the pulley D we have horizontal load. So carefully read the question and identify how we can draw this space diagram. From the question itself we have to write this method. We have to draw this space diagram. Now we can go for the calculation. Here the given data we can write AB is equal to 1 meter, that is the distance between these two bearings, and DC, the diameter of the first pulley, is given 600 mm. Then AC is given, that is the distance between point bearing A and the pulley C, that is equal to 300 mm. The maximum tension is given, we can write it as T1 is equal to 2.25 kilonewton, or the diameter of D, that is the second pulley, that is given 400 mm. Now BD is already given 200 mm. Then theta is given 180 degree and mu is equal to 0.24. Sigma B is equal to 63 and tau is equal to 42. These are the given data. Now we can go for the calculation, that is T1. What is T1 and T2? These are the two tension on the pulley C. So we can write T1 as the tight side tension at the pulley C and T2 is the slack side tension at pulley C. The tight side tension is given 2250 Newton. Now we can find the tension at the slack side. How we can find? Using this equation, that is 2.3 log T1 by T2 is equal to mu theta. If we substitute this equation in our using our calculator, we can find the value because mu and theta already given. Also T1 is also given. And if we substitute T1, mu, theta in this equation, we will get the value of T2. Okay, using our calculator, using our scientific calculator, we can find T2 is equal to 1058 Newton. Now we can find the total value. What is the total vertical load? Total vertical load acting at point C is equal to T1 plus T2. That is equal to 3308 Newton. Now, is there any vertical load at the pulley D? No, because on the pulley D, in the question itself they are given that only horizontal load. So we can avoid the vertical load from there. So there is no vertical load at shaft on the point D, that is equal to 0. Now we can draw the vertical load diagram. I can show that vertical load diagram. This is our vertical load diagram. First figure, that is the figure C. Vertical point A at point B. Vertical load at point C. There is no vertical load at point D. So the mark it as 0. Then next we can go for the horizontal load. Wait. Okay. Using this equation, that is in the question they are given that the torque acting on the pulley C, T is equal to T1 minus T2 into RC. What is the value of T1? T1 is equal to 2250, and what is the value of T2? That is equal to 1058 into RC. RC is already given. If we substitute this value, we will get the value of torque at C is equal to 357.6 Newton meter. We need this value. I can explain what is how it is used in our equation. Now next we can go for the second section, that is on the pulley section D. We can take T3 and T4 for the tight and slack side at pulley D. Here no values are given, so how we can find the values? In the question they are given that the tension torque on the I can show that. Consider this as, that is the torque on one pulley is equal to that on the other pulley. That means both torque are equal. So we calculated the value of T using this equation. That is for the first pulley the value T is calculated. So we can substitute the same value for the second equation. That is T3 minus T4 into RD is equal to same value, same torque value. And if we substitute this value, that is if we substitute the value of RD in this equation, we can write R3 minus T3 minus T4 is equal to 1788 Newton. Now we can take that T3 by T4, that is the tight side by slack side, which is equal to T1 by T2, or that is the value is equal to 2.14127, because the value of T1 and T2 we already calculated, so we will get the value. Now we can convert that T3 in terms of T4, and if we substitute this value here in the previous equation, we can find each T3 and T4 separately. Each T3 and T4. T3 we will get it as 3376 Newton, and T4 is equal to 1588. And similar on the previous section, that is at the pulley C, we can take the horizontal load on the pulley D. WD is equal to T3 plus T4. We can take it is 4964, and at the pulley D there is no horizontal load. At the pulley D we have only horizontal load, there is no vertical load. Similarly at the pulley C there is no horizontal load, only vertical load. So we can draw the another figure, that is the horizontal load diagram, like this. At the pulley C there is no horizontal load. At the pulley D we have a horizontal load, that is 4964 Newton. So we can draw these two drawings on the below of the space diagram. Now we can go for the reaction load at the A and B. We can write the vertical reaction, and first time, that is RAV and RBV. RAV stands for the vertical reaction at bearing A. RBV stands for the vertical reaction at bearing B. The total value for the bearing is equal to 3308 Newton. If we take the bearing value, that is the taking the moment at point A, we can write RBV into 1 is equal to 3308 into 0.3. Okay, what is that value? If we substitute all these values here, we will get RBV is equal to 992.4 Newton. And using this equation, that is first equation, if we get the value of RBV, we can find the value of RAV. What is that value? 2315.6 Newton. Similarly, we can take the bending moment at A and B. Bending moment at A and B. MAV is equal to MBV is equal to 0. Because bending moment at A and B, we consider it as 0. But there is bending moment at C. What is that value? Bending moment at C is equal to RAV into 0.3. What is that value? If we substitute RAV, we find the value of RAV, reaction load, from the previous equation. If we substitute this value here, we will get the bending moment at C. Similarly, we already calculated the value of RBV. If we substitute this is RDV. If we substitute the value of RBV here, we will get the bending moment at point D. What is the value? 198.5. Now we can draw that bending moment equation on the figure. This one equation, vertical bending moment at point C and at point D. We have two bending moment, 694.7 and 198.5. The bending moment figure will be like this for the vertical direction. Similarly, we can find the value for horizontal direction. Similar as the previous case, the horizontal direction, RAH plus RBH, we calculated the value, that is equal to 4,964 Newton. And taking the moment about A, RBH into 1 is equal to 496.0.8. What is that value? That value will become 3,971 Newton. And if we substitute this RBH in the previous equation, we will get RAH, that is H for horizontal direction. And we know that the bending moment at A and B for the horizontal direction is also 0. And for the horizontal direction, at point C and D, we can calculate it RAH into 0.3. What is the value? 993 into 0.3, that is equal to 297.9 Newton meter. And for the point D, or at pulley D, MDH is equal to RBH into 0.2. RBH we calculate from the previous equation. If we substitute this value, we can draw the bending moment diagram for horizontal direction. I can show that figure. This one is the horizontal bending moment diagram. At point C, that is equal to 297.9, and at point D to 794.2. So we will get the vertical bending moment and horizontal bending moment separately. Now we can combine thus we can calculate the resultant bending moment. I can explain how we can find the resultant bending moment. This is the resultant bending moment equation. At point C, we can take the value of vertical bending moment and horizontal bending moment, and take the square value, take the summation of square root of the summation of that square value, will get the bending moment at C. Similarly, we can calculate the bending moment at D also using this method. Thus, we can finalize the figure. Which one? This last figure. We can take the resultant bending moment at point C using these above two values, that is vertical bending moment at point C and horizontal bending moment at point C. If we compare these two values, we will get at point C that bending moment is equal to 756. Similarly, at point D, that if we compare these two values, we will get that is equal to 819.2. And we can continue. Thus, we will get two bending moment, that one is 756 and another one is 819. Now, which one is greater? The greater value is at point D, that is equal to 819.2. We can find the diameter of shaft using this bending moment, because that is the maximum value. We know that the equivalent twisting moment T is equal to root of m square plus T square. The value, if we substitute the value M, we calculated the bending moment, the value here, and the torque we already calculated in the previous section. If we substitute this value, we will get T is equal to 894 into 10 raised to 3 Newton millimeter. And that for the equivalent twisting moment, if we substitute this TE in the previous equation, that is equal to T is equal to 5 by 16 tau D cube. If we substitute the value of tau here, we will get diameter D is equal to 47.6 millimeter. And now next, the bending moment, equivalent bending moment, we can calculate using this equation, half of m plus root of m square plus T square. If we substitute this value, the value of m and T here, we will get the value is equal to 856.6 into 10 raised to 3 Newton millimeter. And if we substitute this value here, if we substitute this value in this equation, that is in pi by 32 sigma b d square. Sigma b is already given in our question. If we substitute this value, we will get the diameter D is equal